Who saw my talk yesterday? Anyone? Okay, so the first slides have nothing to do with my talks, and I'll go fast because they're the same as yesterday. This is like just intro. I work at a company called Christie. We do projectors. What I do is called projection mapping, where you take a bunch of projectors and make it look like one projector by stitching it all together. We do it on really giant screens. There could be a whole pile of projectors on that screen. And we do it on ice surfaces and basketball courts and stuff like that. When you watch the opening of a sport thing. We do it on giant buildings like Canadian Parliament. That's Moscow. There's that at the bottom there. It's a link to a YouTube video of that being lit up, and it's really well aligned to the building. And that's a gray car. Car is whatever color you would like it to be because we project the color onto the car. You can see at the bottom there that it's actually just a dark gray car. So that's not yellow, that's gray. Or red, or blue, and the car's, it's a little model, it's this big. And even the, like the brakes and the wheels and everything, the calipers, is all projected onto the car. And then that's how we do it. You shine some light, shine some patterns, and then you know where the object is. But that's what I do at work. I'm not going to talk about that. I'm kind of going to talk about that. Actually, there'd be a little bit of code from my work, but I'm just going to talk about coding in general. So I guess, nothing in particular. It's an interesting topic, but someday I'll talk about it more in depth. This talk is Words of Wisdom. I'm Tony Van Eerd. Finally put my Twitter handle up there because that's why I give talks, is so that you follow me on Twitter. And who am I to give? So it's Words of Wisdom. They're mostly not my words of wisdom, but do I even have the credentials to edit these words of wisdom together? Well, here's a quote, because it's all about quotes. Tony's code is righteous. Herb Sutter, right? And that is directly from an email to the committee. And Herb even said it was okay for me to show a committee email because it's his email. And the very beginning of it is Tony's code is righteous. And it actually says, and any coding standard that bans it should be dragged through sewage and pilloried. Pilloried is the block thing in the old medieval times. And he just goes on and on about how he's going to not talk about it, how much he feels about it, but then he keeps going on about how great it is. Tony's code follows several good practices that we strongly encouraged. And a little bit of context, this was some sample code about multiple returns as being an okay thing. But I'm sure he wasn't talking just about my one example. I'm sure he was talking about all the code I've ever written and ever will write. I doubt I'm taking him out of context. So, Tony's code is righteous. I'm clicking next. I just really like this slide. I've got 3 copies of it. Bjarne has said things about this is what Bjarne says in committee emails. You say something fairly intelligent once in a while, +1. That's all you get. I have gotten a nice rule of thumb, and I did get a nicely put recently. So I've got about so the +1s and everything. I print them out. I print out the email and I put it on my wall, at work. So if I get an argument with someone about something, I say, no, look, +1. Bjarne said I'm right about this. So anyhow, so here's just when you have multiple courses and a really fancy meal at a fancy restaurant, and it's a multiple course meal, and between each course they give you something to cleanse your palate. So I've got these classic cliches are just something to cleanse your brain for a second. It has nothing to do with my talk hardly. It's to separate sections of my talk. So the first section is this one. So we all know what he said, right? He said, copy or copy not, there is no shallow. Okay? So people get that wrong all the time. I don't know why. They think he said something else. And this is such a fundamental thing in C++. And I've run into it. I had to more explain it in other languages like Java and stuff of should you just copy if you have a class with internal references or internal pointers, should you copy it deep or shallow? And it's there's only one answer to this. Because copying is just the most fundamental piece of C++. And not just Master Yoda, but Master Stepanov, Alex Stepanov, who wrote the STL. He's got this set of concepts of when you construct a thing from another thing, then they better be equal after that construction. And if you assign it, it's also the same. And if you have two things that are equal, A and B both equal C, and you change one of them, then while B still equals C and A doesn't equal B anymore. And the important part of that last one is that when you make a copy, it's distinct from the other one. Like you copy an int, those two ints aren't tied together anymore, right? You don't want, Einstein action, spooky action at a distance when you change this object and this object over here changes, right? You need the objects to be distinct. And that sounds very basic and simple, but we get it wrong all the time, including the committee. But it's fundamental. Like C++ is the only, possibly the only language where you can override the copy constructor, yet the compiler's like, I know what a copy constructor is supposed to do, and I will not call it whenever I don't want to call it. Right? You can just delete, just get rid of that copy, even if it had side effects or whatever, because the language is like, your copy shouldn't have side effects and it shouldn't be doing anything weird. A copy should be a copy. And also think of what compilers do to in optimizations, right? With normal ints and things, native types. Compilers will do hoisting and sub-expression elimination and all these kind of optimizations that they do, knowing how an integer works, that you can make a copy, you can do all these things. And it can't necessarily do that with your classes because it can't be sure what's going on with your class. But if a compiler can't do it, you still do it in your code. All the time you write code, like simple code like this, where you're like, oh, there's the old one, I make a change and I'll return you what it used to be. Or like, that's like a plus plus operator, we'll have to do that, the post increment plus plus. Or just like you just have an expression and you save that as a temporary and then you reuse it all the place. You do this all the time, like you move code around knowing that a copy is a copy. And I can make a temporary and not worry how that affects the other thing. So whenever you write a class that doesn't do that, someone's gonna be confused because it's such an assumption. Yet we break the rule a lot. So that's stepping off. And more from Yoda on this.
Fear leads to anger. Anger leads to hate. Hate leads to suffering.
So what was the last thing he said? The last one?
Fear leads to anger.
Oh, I didn't really mean to do that again.
Hate leads to suffering.
He said state leads to suffering. State leads to objects, right? You've got some state, you want to keep track of that state, so you put it in an object. And okay, now you've got objects. When we've got a bunch of objects, you need to have, people interact with these objects, so you have references to these objects. And then when you got references, and I got a reference and you got a reference, we start sharing these references. And now you got sharing, and now you got entanglement, and entanglement leads to suffering. Right? So state leads to suffering. We have the secondary problem of, programs are all about state, so it's a hard problem to get away from, but we have to be aware of it. And see, that's about objects, and copy and stuff is about values. And you kind of use these terms loosely, but what am I trying to mean here? Typically, something like a button is an object, right? There it is, it's a button. You don't have a copy constructor on a button. You don't just make a copy of a button, because then you would have two buttons showing up in your UI or something like that. Typically, you don't do that. But in some languages like Java and other object-oriented languages, you have objects all over the place, and it's kind of good typically that they're not copyable. And an object is this thing, and it changes over time, and it has a long lifetime. And then objects can have relationships between each other. Where a value is kind of like an int or a string. They tend to be copyable. And I've got these weird words that kind of think, how does this make any sense? That they're immutable, ephemeral, and timeless. How can you be both ephemeral and timeless? And int and string are not immutable, right? But the number 17 is immutable. It's always 17, right? That number will temporarily be in a string, in an integer somewhere, but the number is always 17. The int can change, but that's kind of just a temporary thing that kind of flows through your program usually, right? You tend to have these are types that come and go through your program. That's why they're kind of, on one hand, ephemeral, and the other hand, they're timeless. And you get, math, but I don't just mean math on integers and numbers, but math in general in the sense of you write functions that take values in and they return a value out. And when you do that, then your code is more mathematical, and when your code's more mathematical, it's more easy to reason about. So you have these two, sides to things that kind of fight each other, and you need both in a program. But the question is how much of one and how much of the other. And you got this, especially when I've taught C++ to Java programmers before, and the first thing they worry about is pointers, right? They're like, oh, I don't want to deal with pointers. I'm like, Java only has pointers. Like, you don't think about it, but it's like every reference is a pointer. But now if you work with value types, you can just, it's not like, oh, no pointers, it's, oh, no pointers. You don't need to have a pointer ever anywhere, right? Vector hides a pointer inside of it, but you don't have to ever see it. You can treat it like a value. And with move semantics, you can pass it back like a value, pass it in like a value. And then my question that I often think about and ask other people is the queen of clubs. Is the queen of clubs kind of like an object, or is it kind of like a value, right? And I was actually writing, my kids are always like, why don't you ever write a game or something? So I'm like, okay, I'll write a card game. And it's like, okay, class card. Card has a rank, a number, and then a suit, clubs, diamonds, whatever. And that's just it. It's got a number and an enum in it. And it's like, okay, great. And it's like copy constructor. We're like, that's kind of normal. I was like, wait a second. Should the queen of clubs have a copy constructor? Do I want to end up with 2 queens of clubs in my code? I was like, oh, that's probably, I'm going to screw up if I have a copy constructor on the queen of clubs. So basically this is why I never finished the game. I was like, oh man, this is a tricky problem. Do I make this class kind of like an object, or do I make it kind of like a, and the other thing I should mention is anything that is a value, like an int or a string or something, you can easily make it into an object. Take an integer and make it a static in your program. Suddenly it's object-like because everyone can reference it and everything. Now it's a thing that lasts and acts more like an object. So it's not so much, these aren't like a type is either one or the other. It's kind of the semantics of how you use it. But often when you make a class, you know what kind of semantics you're going for, and you'll lean one way or the other. So I'm still torn on this question of whether the queen of clubs, because there should only be one of them unless you're using a multi-deck thing. But it's in your hand. It's a thing that has relationships as well. It's like in your hand, or it's played on the table or whatever. So I'll let you guys think about that. Ask me later, or tell me later what you think. But there is a philosopher out there, Sartre, who's, if you postulate a universe composed of objects, truth is eliminated. I don't know what that means, but but it's about objects. He doesn't seem to like them. Another philosopher said, Sean Parent, programmer philosopher. Everyone knows Sean Parent. You should watch all his videos. Seriously, every video he's got. He's a developer at Adobe, senior, been there forever. You should all know who Sean Parent is and watch all his videos. He has this thing called incidental data structures, and even though that's not even a complete sentence, I kind of think I know what he's talking about. And so if you have some kind of contact, like a contact person on your phone, that maybe that contact has a location where the person lives, you can think of that, even if it's like 2 separate objects possibly. In C++, you'd probably just have an embedded member, but in some other languages, it might be 2 separate objects with a pointer or reference. You treat the whole thing as a single object, right? As a single data structure. And then you might have another one over there, right? Okay, that's fine. But then you might do something like make a copy that's shallow, or maybe these 2 people are just living together or whatever. They're now sharing a location. Okay, fine. It's still, 2 data structures sharing a location. And Sean's like, no, that is not 2 data structures that overlap. That is 1 data structure. And this is kind of a made-up example, but think of your code base. How much of your code base is filled with objects that point to other objects, and you think, oh, these are all just separate things, but they're all interrelated, and they got pointers to each other, and they're entangled. And Sean's whole concept is find that data structure that is hiding inside your program, and rip the thing out and encapsulate it into an actual class that is like, this is the class that has all these relationships, and this class will manage it. Because right now, in your code base, that management is just spread out all over the place. At least that's my code base. Every code base I've ever seen has this problem of you think you've got all these little data structures that are independent, and you want to keep them independent, but who's managing all the relationships? Those relationships are just like, hey, don't forget, and it's like you tell another developer instead of it just being built into the code. So that's called incident data structure. And I've trying to wonder about that on this problem of maybe the queen of clubs is just a member of a bigger data structure called the deck of cards or the state of the game or whatever, that maybe this will help solve where is the value. Because once you pull out your incidental data structure, like Photoshop, the Photoshop document has this giant image in it and whatever else in it. That's a value type in Photoshop. You make a copy of that when you do an undo. And it's like, wait a second, I've got like this 20 meg or 200 meg image, and it just makes a copy on undo. Of course, it has a very efficient copy. It cheats and whatever underneath the surface, but as a programmer, you just make a copy of the document, and you put it in the undo stack. It magically only copies the part that changed, but it acts like a value type. And that's what everything Sean writes is like a value type. So, and another beautiful Sean, it's my favorite quote from Sean: "A shared pointer is as good as a global variable." And that he means both a pointer that happens to be shared and also shared underscore PTR. For exactly those reasons. I think the quote speaks for itself. It acts like a global variable, and everyone knows those are bad. And so shared pointer is overused. And if you don't trust Sean, we can go to Shakespeare. Neither a borrower nor a lender be. Okay? So that's that. Let you think about that while I figure out what's next. More Star Wars.
Only a Sith deals in absolutes.
Obi-Wan Kenobi on signed versus unsigned. Right? This is a raging argument in the committee and in the C++ community about whether you should use signed or unsigned integers for many things, like size of a vector or something. Obviously, only a Sith deals in absolutes. You should use signed, not unsigned. And here's my example. I'm writing a square root function. I only handle unsigned numbers, so I say unsigned int, and it's not the most accurate square root, but it's very fast. I'm using test-driven development. It's currently working. So far. But anyhow, maybe I decided to use an unsigned int because I'm like, I don't want you to pass negative numbers into it. I can't handle negative. So far, I could probably handle negative numbers fairly well, but if I improve this function, I probably won't be able to handle negative numbers. So I don't want you to be able to call it like this, right? Yeah. Well, that's the problem. It's like, oh, isn't this a compile error? No, it's maybe at best a warning. See? So I'm not preventing anything from happening. I'm making it not my problem that you passed a bad integer, but it's not really helping that much. Not as much as I would like. And here's a better example, because this does not give a compiler warning. And I've tried it on a number of compilers of warning settings. I haven't been able to pull a warning out of this. But there's a bug in there. When the vector is empty, it goes off the end. All right? And this is not exactly, I shortened it to is sorted as kind of a simple example, but this was straight out of our code base. We were doing something bigger, and of course the function was this big, and this was just a little part of it, and it was comparing things beside each other, and it said -1, right? And we happen to never have an empty vector. So, is it a bug if it never happens?
Well, even then, on a vector of 1, it's going to be...
Yeah, vector of 1 even. Yeah, what do you...
That's not going to work anyway.
Yeah, it worked. Like, it's the classic, it's not correct, but it works, right? It's just because we always had lots of data. And this is my answer to, should you use signed or unsigned? People expect numbers to work like numbers. You expect to be able to do subtraction, and it just does something sensible. Unsigned numbers do not do sensible thing of subtraction. They put you off on the other end. Like integers at the ends don't do sensible things either. They overflow and underflow. But unsigned numbers do it right near 0, where all your numbers are, all the numbers we typically use. So I like to avoid unsigned numbers. And this is the nicely put from Strustrup. So don't argue with me about this. And if you really want to argue about signed versus unsigned, you have to argue against all these people. Which you can go find the video, the links there and everything. I've given you the time codes of where they talk about signed versus unsigned. And the last question someone asked them was, why does standard vector and all the standard things returned unsigned with size? Size t is unsigned. And they said, sorry. And someone else said, we were young and foolish at the time. I would like to do better. And unsigned would be great if it was a stronger type. But we inherited the C rules of conversions and stuff. So I would like to do better. I would like to make my own type, like unsigned int or something, my unsigned int that would be stronger and give me compiler errors and maybe throw or do something. And I haven't done it for int, but I've done it for this case where I have a string, right? And this is my code that does projector stuff, and I also have another function, hello, that gets camera. It also takes a string for the ID. And obviously, you look at those two and you think, oh, someone's going to pass a camera ID to the string function and pass a projector ID to the camera function. They're going to mix them up. So I wrote a strong ID class that says, it wraps a string but gives it a unique type. So now you can't mix up camera IDs and projector IDs, nor can you pass a string in because it won't automatically convert to an ID. And that's because of the keyword explicit. So this quote is from the keyword explicit. And I have a whole paper in the committee on which things, including like when someone proposes something for the committee, should the constructor be explicit or not? And I've been told that half the reason they said yes to me talking at this conference is because of this thing called Tony tables. And everyone's like, you did Tony tables? And they're just like tables we use in the committee. This is this is only a Tony table because it's a table that I made, but it's not the classic Tony table. It's a different kind of table. And it's really complicated and hard to understand. But if you think about some class you're going to write, in your middle of writing a class, you got that in your mind, and you're like, this class is going to take a foo as a constructor. And then you have to think about, is this foo, as a constructor the same as, I should just have an example. Here's an example. Image class, right? It takes a char star file name, which is bad for other reasons. An image class should not be the guy doing the reading. That should be separate. But if you have an image class that takes a char star in its constructor, well, is a char star the same as an image? And you're like, no, those are not the same thing. I'm not trying to model the same Platonic thing in the sense that integers try to model the concept of number, right? And a string and a file name, or a string and an image are just no way the same thing. So this should be explicit because it fails my first question, right? And then there's a whole bunch of other questions are like, well, the integer and double try to model the same thing, but you lose information. You got fidelity loss. So maybe they should be explicit, but we're stuck with what we have for that one. And then a whole bunch of other questions about that. And then your idea is you go through the table and you check off where are you, and wherever your checks are to the right, that answers your question, right? If you've got even one check in the middle column there, then you should have an explicit constructor. And the farthest column is things like toString, right? Not only do you want to be able to convert an int to a string, but you don't want string to have an integer constructor. You don't even want it to have an explicit constructor because like toString is more of an operation you do. So you want it to be an actual function name. So the final column is for things you want to be a named function. And the important one is the bottom question, are you sure? And if you're not sure, then make it explicit, right? So that's why you have to answer yes to that very bottom question. So this is in progress with the committee. I got to update the paper, but it's on my GitHub. Because right now the committee sees proposals come in, and we argue about each one differently every time we argue about them. And it's like we should have a standard, kind of model for how we make these decisions. So. And this was AE. Anyone know what that stands for? It's almost always explicit. That's always the answer you want. And if you want a strong ID class, I've got one on GitHub, and there's like plenty of others out there. I just got like one class. These other people have full, kind of libraries of strong types. Really useful. Oh, right. Yeah, you got to think about these things. In addition to these quotes from people that I know and read about, we've got some ancient C++ cones that have been uncovered. And we're still trying to figure out where these things come from. Almost all of them are exactly 140 characters. But recently we found this one, which is 280 characters, so I'm not sure what's going on there. But the story is that the master is, walking his dog, and he visits his student. And he's like, oh, I was just out walking my dog, but while I'm here, I wanted to ask you about this new function you're writing, and why do you pass in big common struct instead of just x and y? And the student is like, well, big common struct is where we keep x and y, so obviously I'll just I'll just pass that in. That's the way we do things around here. And then the dog barks. And master's like, oh, sorry, my dog's hungry. And the student, of course, he's like, oh, let me prepare a meal for your dog. Please let me, prepare some food for him. The master's like, oh no, that's fine. Just open the fridge door. Let the dog take what he wants. So I don't explain cones. They're just there for you to think about. That's the whole topic. That's just one slide. There's a whole bunch of cones out there. I don't know where you might be able to find them, but they're all 140 and 280 characters. What's in a name? That which we call rose by any other word. It's interesting that by any other word or by any other name would smell as sweet. There's like multiple copies of Shakespeare out there, so you actually can't get the exact quote. Depends on like which version of Shakespeare they dug up. Not the person, the papers. Actually, people have done experiments on this, and turns out roses don't smell as sweet if you give them a different name. Yeah, they put scents in front of people, not knowing what the scent was, and told them, here's the scent. It's called this, and turns out names are important. So, finally, a quote from me: "Essence is the essence of naming." I have one day I will have a talk just on naming, but it's basically all on this slide, and I'm not going to go through all these things because I don't have time, but. Determine essence is right. What is this thing that you're creating? And you would think you would know. You're writing a class, you know what the class is, but 9 times out of 10, it turns out you don't know what the class is. At least that's what I find, whether it's me writing it or whoever's writing it. A recent one was in the committee called span, and a span is like string view, if you know string view. It's just like, it points to some array of things, and it just has a begin and end. It says, there's these things over here. I don't own those things, but I can tell you that there's 27 integers, and if you want access to them, it's like a begin and end iterator packed together. That's all it is, right? It's just a pointer and a length. So then the question is things like, should span be regular? And regular was those stepping off things at the beginning. It's like, what happens when you copy a span? What does equal equal do? All these things. It's like, does it work like an integer? And the question in the committee was, what should span equal equal do? Should a span be equal if it points to these elements and those elements, these two spans have the same, all the elements are equal? Or are two spans equal if they point to the same place, right? And either one makes sense depending on, well, what do you mean by span? And so I wrote a paper. This is actually straight out of my paper. I write ASCII diagrams as committee papers sometimes. Not only tables, I also do ASCII diagrams. And my first point is that if we can decide whether span should be regular or not, we should name it properly. So if two spans are equal because they happen to reference things that are equal, then it should be called a spanning ref and it has reference semantics. But if a span is just a pointer and a length, then two spans are equal if they point to the same place. And then you call it a spanning pointer, and everyone knows how pointer equal equal works, right? It works by just the pointer equal, not, is equality deep or not? And then you get these other questions about is const deep or not, and all these other things. And there's some answers I think are not good answers. But the problem with it is we have this type called span, and it's like, oh, it does some cool stuff. We kind of put some stuff together, and it's like, okay, but what is it, right? If you can't answer the fundamental questions of what does equality do, what does copy do, and stuff like that, then you really don't know what it is you have. And if you don't know what it is, and the other half of that is, if you can get the right name for it, then any follow-on questions that come up later, like string view, we've had questions come up like 2 years later. People are still like, well, what do we mean by string view? It's like, if you can get the right name and nail it down, then every other question becomes clear. And the other half of it is, if you don't know it, if you can't name it, you don't know what it is. If you don't know what it is, you don't know what it isn't. And if you don't know what it isn't, you don't know what code shouldn't be in it. And most of the code shouldn't be in it, right? We got code just like people throw code into this function because, well, that's, I throw another if in, that solved my problem, right? It's like, is that where this belongs? And if you can name your classes and name your functions well, then it'll be clear that, oh, this doesn't belong here, and you'll put it in the right place. This is just me ranting on Twitter. And the number one rule of naming and the number one rule of API design is just be consistent. And then just recently added an addendum to that called consistent warning signs. And yeah. I had this problem with, I wrote this strong ID class, and it's like, great, you can't convert from string or not. But every now and then you do want to convert the strong ID back to a string because maybe you want to print it out or some function takes the string. And people will be writing, take string, projector ID, dot, and they're looking for the function that gives me the string out of the ID. And know what function they find? They find dot operator string. And they're like, okay, that does it. And then they continue on and they leave that in the code. Which is like, that's not how you call operator string. But because of an IDE, when you type dot, it shows you the list of functions. They just take that function, right? So I need a function name for how to get this string, how to get the value out of an object that wraps the value, how to unwrap the value, get the value out. Unwrap an object, get the value out. So what should I name this function? Anyone? Any guesses? Value. Yeah. See, this. I said 3 words. I tried to say 3 words: unwrap, get, and value. I think those are your choices, right? And I think unwrap is actually a good name for a lot of reasons because it's a very unique name. You can search for it in a code base and find it. But I have this idea of consistent warning signs, so I use the name get, which is a really bad name because it's very generic. But things like shared pointer, unique pointer, all these things that use get is the sign of like, oh, look, I'm going to unwrap this object that was here to protect something. I'm going to crack it open and kind of I'm going to do something a little unsafe. So there's a little bit of a warning sign with .get. And whenever if I'm doing a code review and I see someone calling .get on a shared pointer or something, I'm like, oh, why do you need the raw pointer here? Why aren't you just using the shared pointer? And so I want that same warning sign. When I see someone using .get on my strong type, I'm like, why are you opening up the strong type? You should keep a strong type as far as possible. And you can look at the code and go, oh yeah, I see why you needed to do that. That's fine. It's not a terrible thing, but it's just a little warning sign. So I picked the name because it's already a warning sign in at least anyone who does a lot of code reviews. So I think that's a good reason for naming something. And then if you can be consistent, which is really, really hard. I mean, Qt is a really good example of consistency. Even things I don't like about Qt, but they're very consistent with how they name things and do things. If you can be really consistent, then you have this thing called be glaringly inconsistent. And I have an example of that. In C++, we got optional. We're about to get an expected. And we have an any. And all 3 of those things can either hold a value or not hold a value. The expected either holds a value or an excuse for why you don't have a value. But the other 2 will just be empty. So you can ask all of these things, do you have a value? And then we have standard variant, which can have multiple things in it. But it's very much similar to the other ones. An optional is basically a variant of float and nothing. An expected is basically a variant of those 2 things. And the general variant can have like as many types as you want. But what should its empty state be called? Should it be have an has value function? And almost, it has a valueless by exception function. And it's like, wow, that is a little different. That is glaringly different than all the other ones. Because it's different. It's meant to be different. Because the thing with a variant, it should always be a float or an int. It should never be empty. It's going to be one or the other. There's this one little corner case where it can get empty, and it's only because you threw an exception at a really bad time, and you should basically never ever call this function, never worry about this case, but it's there in case you have to. Maybe in a catch clause. But basically, the other 3 functions are normal things to call. Go ahead and call them all you want. This last function, if I see it in code, I'm going to be like, what are you doing here? Why are you doing this? Why can your variant get empty? It should never be able to get empty. So that's how to have, if you have consistent API, then you should be able to have when someone sees something that's, wait a second, this doesn't look like the rest of the stuff. That should make you stop and think, I should go read the document on this and understand what's going on here. That's what glaringly inconsistent does. And that's the nice rule of thumb from Strustrup. Yay for me. That's naming. In sooth, I know not why all code's so bad. It wearies me. I say it wearies you. This is the opening line from Antonio from the merchant or coder of Venice. I think it's the coder of Venice. It's another one of these cases where we're not sure exactly what Shakespeare wrote. He wrote a lot of things. It was a version of the play. I like this version better. It's like, in sooth I know not why I am so sad, it wearies me. It's pretty much the same quote. And this is like, this is a rant by Antonio in The Merchant of Venice. So here's my rant. Everything is just like, keep your code independent. I don't care about OOP. I don't care about what language. I don't care where you put your brackets. Just separate your code and name things well. And name things well because naming things well helps you separate your code, among other things. And my other, it's like a continuation rant of, you see everyone who does abstraction, like, oh, I've abstracted that into a class. And then you go look inside their class, and their class is a big pile of mess, right? It's like, why didn't you keep abstracting things inside your class? Didn't want to say mess and then say, oh, here, I have an example, because this is not a mess. Jonathan Bacara has a really good blog on Fluent C++. Is his blog. And he had this one thing about, in this particular case, should we use a map or a multi-map or a map of vectors? And basically, his case is he's writing, another event system that we've all written where an event happens, whether it's an email or a button click or whatever. An event happens and you've registered some people who want to listen to that event and you call them all, right? So you can either do that with a map from the event to who wants to hear it and have a list of people that want to hear it. And there's the second event with a list of the listeners. Or you can do it as a multi-map where it's one-to-one, but you can have like three foos in your multi-map, each pointing to one listener. And it's like there's reasons to do either one, and that's really what his blog is talking about, is what's the good and bad of doing it either way. So his code is purposely done to show the differences between these two. So this is the first case where you have a map to a vector, and so you just do a find, you get the vector, and then you iterate on the vectors. Yep, and then you call everyone. Right? The other one is the multi-map case. And in multi-map, you call equal range to get all the entries that equal that event, and then you iterate from the beginning and end of that sub-range. Very similar code, and then he talks about how, one of the first piece of code is kind of double indented, and there's other reasons to slight differences. But basically, both pieces of code are like, go get all the listeners and then call them all, right? So the thing that really piqued my interest was that I had just written the exact same thing, and almost to the same. Like mine is also called mediator. Like it's like the same. And I went and looked at my code. And my code looks like this. It's like get listeners, call the listeners, right? So which data structure did I use inside my class? Did I use the map of vectors or the multi-map? Who cares and who knows, right? It's like this function here doesn't care. This function is just exactly what you think of what the function should have done. Get the listeners, then call them all. Right? So I was kind of happy. I was like, it's not like I refactored the code to this point. I just wrote it this way because it's just like, why not write the code this way from the start? And again, Jonathan was writing example code for a certain reason, so I'm not saying his code was bad or anything. But I was like, this is how we should write the code, because it's just you see it all the time where once you get inside a class or inside a function, you're like, all your abstraction goes away. It's like, no, you can stay abstract for a while. Code looks cleaner and better. And then, of course, I went and looked at my own code. And this is like some lock-free code that I wrote on the left-hand side there. And lock-free code especially is kind of code where you're like, I want to know the state of everything. I want everything right in front of me. I need it all here now because it's complicated lock-free code. But then I was doing it in a talk, and I was like, I should listen to my own advice and write the code like that over there. Because this code, I don't know what it's doing. The code over there is like, it's a lock-free queue. So first thing you have to do is find the tail. You try to write to the tail, and if it fails, you loop around, and then you reset the tail at the end, and you leave, right? It's like 3 lines of code. Whereas over here, I don't know what's going on. So I don't abstract properly. None of us do, right? Bjorn often asks the committee for what's the real feature that's going to change the way we code? Like what's a really impactful feature? So one time I said, let's just limit the size of functions. Like we'll start at 50 and we'll just cut down from there. We're just like, does not compile if it's more than this big. And like that will change for the better all our code more than any other feature we could ever add to the language. Right? We have this problem with backwards compatibility that we don't like breaking that much code, but Even if we started this big and we just kept every release cutting it back, right?
Have you got his reply to that?
He gave me a +1. I don't know. I can't remember. Yeah. So I'm almost out of time. Yeah. So my question is like, why don't we write better code?
Wait a minute. How did this happen? We're smarter than this.
Apparently not.
Right. Apparently not. Because all the code I've written, all the code I've seen, our code, I mean, it doesn't always start out bad, but it just gets worse over time, right? Everyone just adds to that function. It gets bigger and bigger. And why is our code not good? The usual answer is time crunch. I don't have time to write good code, right? I've often found that, I remember being like 6 months behind on our project. So we're just cutting corners, right? And then 6 months later, we're a year behind on the project and we're tripping over the corners that we've cut before. And it's like, time crunch is not always a good excuse, but I think there's another excuse of instant gratification. You want to write some code as fast as you can and see it work, right? And you don't care about anything else. And when you're fixing that bug, all you want to do is see that the bug is fixed. So if I just add another if statement here, that fixes the bug and I can go home. And you want that, you want that quick loop of show me the code running and then I can, see it. And everyone knows the 80-20 rule, but to me, the 80-20 rule is kind of like, not that I run marathons, no, but marathon runners talk about hitting the wall, right? And how many times are you working on a project and you're like, I'm 80% done. And, management is like, oh yeah, you're so close to being done. And you're like, actually, I'm hitting the marathon wall. I am dying here and I can't get this last 20%. Like that's how often, so that last 20% is where we just really, the code goes downhill. And the question with these excuses, we think, well, what can we do about it too? But the other one is uncertainty. It's like I can look at some code, I can be writing code thinking, I don't think this is quite the right way to do it, but I'm like, I'm not sure what the right way is, so I just keep going, right? And I think that's sometimes that's just confidence and stuff. It's just like, no, just or if it's not the right way, keep trying things until you get the right way, which goes back to take the time. But sometimes I feel people are just uncertain about their first instinct of what's good and bad. Because usually, looking at code later, you can see the difference between good and bad code. But, I can say that's bad, but I can't tell you what the right answer is, right? So it's hard. But, we're smarter than this. What can we do about it? Pair programming is often, can help. It helps keep you from, the bad habits or whatever. And that whole thing about like hitting that wall of the marathon, it's like, and everyone, sprints. Everyone talks about sprints. I'm like, man, if I sprint all the time, I can't run a marathon by sprinting constantly, right? So, when you've done that 80% and you're hitting a wall, get some help. Get someone else to help with you. Make it a relay. Hand off a little piece of it. Get some other people to work with you. And as a senior developer and stuff, positive feedback. I work on a team that just in our stand-ups and stuff, someone will say, oh, so-and-so helped me with this thing yesterday. That's what I did yesterday. So, thank you for helping me with this thing. And it's just like this little positive feedback, and then it's like contagious. Like all we do in stand-ups is thank each other. And it's like, great. It's awesome. But I'm trying even in code reviews, because if you're doing a code review and it's good code, you don't say anything at all, right? You just like, oh, yeah, that's fine. Then you find something, oh, I'm not sure about this. Can you explain why you did this? You just, complain about some small bad thing. You put the bracket in the wrong place, or just, actual code that's bad. But I'm trying to get into this habit of like, if I fly through a code review and I've gone through 2 or 3 files where I don't have anything bad to say, I should say something good. This code is decent. Thank you for writing good code. Anything to give that positive feedback, so that next time when they think I should just hack this in, then people think, no, I like that positive feedback of writing good code. And for the instant gratification loop, writing tests is a good way of getting that instant gratification of, does this work? Well, write a test and see that it works. And then when you get a big set of tests, you start feeling like I'm doing something. Like things are working. I've got these tests working. And similar to the positive feedback, praise publicly. I'm starting to think, gamify. Do I need to like give out prizes for fixing bugs or writing good code or something? I don't know. And visualization, like athletes when they're trying to like do high jump or run a race something, they visualize jumping over the thing before they actually do it. And it's like this Bruce Lee quote, a goal is not always to be reached, it often serves simply to something to aim at. And that's what I try to do in my coding is like, how do we want this code to look eventually? Which way are we going? And we don't have to fix all the code now. Just make sure we're going in this direction. That's something we try to do. Whew, and I think I'm just on time here. These are, I purposely tried to make the colors clash as much as possible and also not line up because that's just like jarring. So anyone know what the point of all these cliches, clash of cliches is? Obviously they're all opposites to each other, right? And they're all good advice, right? Even though they're opposites, they're all good advice at times. So I gave you a bunch of words of wisdom, but that doesn't mean, you know, the opposite things are not also good advice. You know, take it all with a grain of salt, basically, is what I'm saying here. And that is the end.